Welcome to this lesson on the reflection of sound and echoes. Sound is all around us, and understanding how it behaves when it encounters different surfaces is fascinating. In this video, we'll explore how sound waves bounce off surfaces, creating the phenomenon we call echoes. This is an important concept in physics that has many real-world applications. Sound reflection occurs when sound waves encounter a surface and bounce back instead of passing through it. Think of it like throwing a ball against a wall, the ball comes back to you. Similarly, when sound waves hit a hard surface, they don't just disappear or get absorbed completely. Instead, they reflect back toward the source. This behavior is similar to how light reflects off mirrors. Hard and smooth surfaces are especially good at reflecting sound waves. The process of sound reflection happens in 3 clear steps. First, a sound wave travels through the air away from its source. This could be your voice, a musical instrument, or any sound-producing object. Second, the sound wave hits a hard surface like a wall, mountain, or building. Finally, the wave bounces back toward the source, traveling through the air once again. This entire process happens very quickly, but under the right conditions, we can distinctly hear the reflected sound. An echo is the reflected sound wave that reaches your ears after bouncing off a surface. When you make a sound, you hear it immediately. But if that sound reflects off a distant surface and comes back to you, you hear it again, that's the echo. The key characteristic of an echo is that you hear the same sound twice, once as the original sound and again as the reflected sound. The echo is essentially a repetition of the original sound caused by reflection. For an echo to be heard clearly, 2 specific conditions must be met. First, there must be a minimum distance of at least 17 meters between the sound source and the reflecting surface. This distance is crucial because sound travels very fast. Second, there needs to be a time gap of at least 0.1 seconds between hearing the original sound and the reflected sound. This time delay allows our brain to distinguish between the original sound and its echo. If the reflected sound comes back too quickly, our brain perceives it as a single prolonged sound rather than a distinct echo. Echoes occur naturally in many environments around us. In mountains and canyons, when you shout, your voice travels across the valley, hits the cliff face, and bounces back, creating a clear echo. Large empty buildings like auditoriums, gymnasiums, and halls often produce echoes because of their hard walls and large open spaces. Tunnels and bridges are also common places where echoes occur, as sound bounces repeatedly off concrete walls. In open valleys, sound can reflect between opposite hillsides, sometimes creating multiple echoes as the sound bounces back and forth. It's important to understand the difference between echoes and reverberation, as they are both caused by sound reflection but create different effects. An echo is a single distinct reflection of sound that is clearly separated from the original sound. It requires a large distance to occur. Reverberation, on the other hand, consists of multiple rapid reflections happening in quick succession. These reflections blend together, creating a prolonged sound rather than a distinct repetition. Reverberation typically occurs in enclosed spaces where sound bounces off multiple surfaces rapidly. While echoes are heard as separate sounds, reverberation makes sounds seem to linger or sustain. The principle of sound reflection has numerous practical applications in technology and nature. Sonar technology, used by ships and submarines, sends out sound waves that reflect off underwater objects. By measuring the time it takes for the echo to return, the system can determine the distance and location of objects underwater. Echolocation is used by animals like bats and dolphins to navigate and hunt. They emit sound waves and listen to the echoes to build a mental map of their surroundings. Medical ultrasound uses high-frequency sound waves that reflect off internal body structures, allowing doctors to create images of organs and developing babies. In acoustic design, architects carefully plan concert halls and theaters to control sound reflections, ensuring optimal sound quality for audiences. Let's summarize what we've learned about sound reflection and echoes. Sound waves bounce back when they hit hard surfaces, a phenomenon we call reflection. For echoes to be clearly heard, there must be at least 17 meters of distance and a time delay of 0.1 seconds between the original and reflected sounds. Sound reflection is not just a curious natural phenomenon. It powers important technologies like sonar for underwater navigation, ultrasound for medical imaging, and echolocation used by certain animals. Understanding how sound reflects helps us appreciate the physics of sound and its applications in our world. Sound reflection truly shapes the way we experience and use sound in everyday life.
If you like this video, hit that like button and don't forget to subscribe. Visit codelucky.com for more such useful content.